Hey everybody, welcome to another episode of Earthly Headlines. I have a pretty good one today. It comes from sciencemag.org. I really like these kinds of articles that go over like new technology and new research techniques, and this is one of those. And it takes place in a prehistoric site in Turkey called Kiloyear. It analyzes animal fat that they found on ancient pottery, and it's a really interesting story. But to give you a little bit of background on this, it revolves around this event, not quite the Younger Dryas event, but it's a different cooling event, which is called the 8.2 Kiloyear event? Yeah, 8.2 Kiloyear event, which is basically 8,200 years before present, so 6,200 BC. And there was at least in the northern hemisphere, it was a wide range of cooling and dry spell. So here's a quick rundown of it. In climatology, the 8.2 Kiloyear event was a sudden decrease in global temperature that occurred 8,200 years before the present. It defines the start of the North Grippian Age and the Holocene epoch. So the Holocene is what we live in now, which is like kind of an anomaly when you think about it, because it's for the most part, the trend is a warming trend, and it kind of kicked us out of the last ice age, the height of the last ice age, about 12,600 years ago. So it's defined here as milder than the Younger Dryas, but more severe than the Little Ice Age, which we talked about last time. And it's a significant exception to the general trends of the Holocene climactic optimum. Now, all this was what you would call like people, climatologists knew about this, but they didn't really know how it affected the people who actually lived during that time. So that's what this article kind of explores here. They found more about the 8.2 Kiloyear event. They found it shows in the Greenland ice cores. If you guys don't know what the Greenland ice cores are, it's basically these group of researchers, these American and I think Swedish, I'm not sure, some European researchers. They drilled like a 2-mile hole basically, and they cut out the core, and then they analyzed it to check the isotope data, and from that they could kind of extrapolate what happened, like what catastrophes happened in the past, and you can see the trend line all the way up to the present day. And it's a really, really invaluable piece of data that we use to refer to. It's kind of like sedimentary data, but for ice and climate, I guess. Someone's gonna get mad at me for saying that, but that's how I understand it. But in this case, we're looking at the 8.2 Kiloyear event in the Mesopotamia and southern Anatolia, this region, and it was it set off a 300-year aridification and cooling episode, which is basically a dry and cold episode, and it may have provided the natural force for Mesopotamian irrigation, agriculture, and surplus production. So this is really interesting. This kind of what's being proposed here is the sudden change in climate made the humans who were living at that time become resilient and adjust. And this might have set them on the path of agriculture and plant cultivation and all that stuff, which is really interesting. This is like more evidence, or I guess at the very least circumstantial evidence, that people were set on this course by a bunch of different factors. In this case, climate is one of the factors. So moving on with the article, they found remains of animal fat on broken pottery, which is really interesting, at this site called Kiloyear, which at the time was a huge city by their standards, about 10,000, 15,000 people. There's all kinds of stuff that they found up to this time, and they were raising sheep, goats. They were in the thick of agriculture and domestication of animals and stuff like that. And so these were real city slickers of the time, if you were to compare it to hunter-gatherers and stuff like that, or people like that rather. A team of researchers led by biochemist Melanie Roffé-Salke and Richard Evershed of the University of Bristol in the UK, and these other archaeologists from Poland. I can't say their name. Adam Mickiewicz and Arkadiusz Marciniak. That's a cool name, Arkadiusz. So they started digging through these ancient trash piles, and they found these fragments of clay pottery, otherwise known as Potsherds, and they dated precisely between 8,300 to 7,900 years ago. So this is a very specific time period. The clay pots they found were used to store meat, and then they found well-preserved animal fat residue in pieces of the potsherds. And what they were looking for was a chemical signature of dietary stress. So what the cattle were eating, the plants that the cattle were eating, they could find from the fat residue of those cattle how, quote, stressed out the plants they were that they ate. Meaning stressed out, meaning at the time when this 8.2 Kiloyear event happened, when everything got drier and colder, you could see it in the structure of the plant, in the chemical structure of the plant, and we'll get into that right now. So here's the technique that I was talking about earlier. It's called gas chromatography mass spectrometry. Gas chromatography mass spectrometry. Okay? So they identified elemental variants known as isotopes. You guys know what isotopes are, right? So they looked at the hydrogen isotopes specifically, and they compared the ratio of the isotope deuterium, or heavy hydrogen, and they noticed that it rose, the ratio rose 9% in relation to the other hydrogen isotopes. But this discrepancy was only found in the potsherds dating 8,200 years. So it wasn't in the ones later or earlier. So it was very localized in terms of time, very localized piece of data that we've got here. So the previous research on plant chemistry has shown that lower precipitation rates correlate with higher ratios of heavy hydrogen. So they found that in the plant chemistry. So since the 8.2 Kiloyear event was, a drying event, you could see the ratios. I mean, you could see it in the plant chemistry by looking at these ratios, which is incredible. Talk about forensics, right? They produced their events and the proceedings of the National Academy of Sciences, PNAS. You guys can, I'll have a link to it in the description. But this is the first direct archaeological evidence of this phenomenon. The phenomenon being how the plants adjust to the lack of precipitation in the air. What this means is scientists will for the first time be able to accurately recreate climate conditions for other ancient societies. So they could, okay, let me just kind of break this down a little bit further. The scientists, they could better accurately create a context of climate in the time of when these people lived. So they could kind of paint a better picture of what they were dealing with physically. And then from there, they could extrapolate all kinds of other data. They can make assumptions, or they can make safer assumptions about the decisions that those people made and why their society went in the direction that it did. It's not going to answer every question, but again, these are valuable pieces of the historical puzzle that we're always, that's ever changing, and we keep adding on to every day now, it seems like. There are other finds from Çatalhöyük that kind of supports this, although they're not as strong as this cutting edge data. But like this one, animal bones that have a relatively high number of cut marks, suggesting they were butchering for every last edible bit. I don't know how strong that is. I mean, I think like you can't really blame that on the scarcity thing, although you could. It's kind of a stretch, but this one makes a lot of sense to me. Cattle herds shrunk while goat herds rose, and perhaps because the goats could better handle drought. That makes a lot of sense. Or a camel, something like that. They probably those populations probably rose, while the cattle, they couldn't handle the dry spell, so they probably either died out or they just weren't. It wasn't worth it to harvest them, or whatever it was. That makes a lot of sense. And then there's an architecture. Their architecture changed, but then there's evidence that their architecture was always changing even before this. So I would say that the goat herds population rising is really that's really compelling to me. But the bottom line here is the discovery of this new data shows how these climate shifts can alter human society. And because of that, hopefully, ideally, they'll go back and review more history and kind of fill in or create a quote higher resolution image of the past using this data, and kind of extrapolate from there what was really going on. And I think here's the abstract, by the way. They present a high-resolution record of stable hydrogen isotope composition of plant wax across 8.2 kiloyear before present climactic event to characterize patterns of precipitation and changes in atmospheric circulation in the eastern Mediterranean region, or southern Anatolia, which is modern-day Turkey, essentially. So I'm going to post a link on both of these. You guys can have a look. Tell me what you guys think in the comments. I think this is huge. I can't wait to see what else they're gonna analyze, because there's all kinds of potsherds in that region, in Turkey, in modern day Israel, Jordan, the Euphrates and the Tigris River, all in the Middle East, all in the Fertile Crescent area. There's all kinds of potsherds there, and hopefully they'll find more with this animal residue. And this is really, I'm geeking out over this, because they're going to have to comb through, like go back and revisit all these sites. I mean, if you're a responsible researcher, you probably should, just for the good of all the science. I don't know who's going to do it, and I don't know how much money it's going to cost. I don't know how much it costs to do these, what you would call, use this technology, this research technique, this, analyzing the isotopes and such, but it doesn't seem like it's too difficult or too time consuming. So I don't know. What do you guys think? Do you think am I geeking out over nothing? Is this just garbage reporting, or does this really excite you to figure out like there's a chance that there's some whole new context that we haven't even examined yet? And imagine if we cross-examine it with other stuff, and what else we're going to find. Like, I don't know, off the top of my head, a biblical verse or something, or something written in another old text, like in the Epic of Gilgamesh or something like that, or even in the Dead Sea Scrolls. The possibilities are endless. I mean, imagine if you're a researcher, like a religious scholar, and you've researched... I don't know. Okay, Dead Sea Scrolls. Let's say that. Let's say you're John Marco Allegro or something like that, and then you take bits and pieces of what you think at the time is interesting, but then you kind of gloss over other things that you don't think are as important. But then now, in light of this new technology and this new context, maybe if you go back, maybe some of the parts of the scripture that you kind of glossed over, you can shine a new light because of these techniques. It makes a lot of sense to me, and I think they should really keep going back with the fine-tooth comb now that we have this kind of climate information. Like, we're armed with this information now, and we can kind of use it to like maximize our efforts, so we can keep building this image of history, and then we'll see what we get. So please tell me in the comments what you guys think. I think this is great. Again, I'll link in the description below all the actual article and then the scientific article. All right, have a good one, guys. I'll see you tomorrow.